Hello, my name is Joel An, and the topics that I chose to present is the greatest player in NBA. So, what's the motivation for this project? That since uh, Michael Jordan has been the topic of NBA for quite a long time, and since then nobody's came along. At at this point, there's a player called LeBron James. He started winning or starting a lot of couple of NBA titles, and there's a conversations started coming up. Hey, he might replace Michael Jordan because he's very good. But the question is, how do you compare these two players? They're never met. They never play against each other in their career. So this is the main challenge. So before I started, I looking through existing visualizations, and the first one I found it's just from Bucket.com, which displays the player bio and player bio with the line chart and shot charts. It is really advanced. It is interactive, but it is not what I'm looking for. Yeah. The technique and colors and everything is really good. It's done professionally, but it's not what I'm looking for. And the second one I found is from basketballreference.com. It shows all the information that I needed, how the player performs, but it's in the table format. You can compare players on the site, but it's in a table format. It doesn't involve or visualization. There's not visual information about. It doesn't plot anything. It's general. And the rest are like this. These are the scatter plots and these are picture plots. And the one thing I found, a couple of projects I found by students. The one's on Kaggle, and the other one is on. The other one is on. Uh, the other ones are rpubs.com. They have decent project. They didn't do analytical stuff. They only plotted uh, what the data set gives them, and they just show it. And they use some kind of box plots and or density plots. But I want to show more than that. I want to compare detailed comparison how the play performs. So I'm looking forward to do it and find out what's it's gonna be like. So before I started working on a project, I collected data and I decided what kind of methods I'm going to use on the project and the procedures come along with it. So for data, I collected my data from Kaggle and NBA.com, and I used one of the API provided by GitHub.com by these two guys, and the other one, and I used Kaggle or Kaggle site, and I downloaded the CVS file. For NBA.com file, I have to process this a little bit. For methods, the methods I'm trying to use is statistical analysis, and to find out how the player performed. The eye test, which is what do you see in a player? What do you like in a player? So, and the final step is awards and accolades. That's how the player perform and accomplish in their career. And I want to do it through visualizations, a combination of visualization and statistical analysis form. And so let's see. So before I start doing it, I have to define what the terms as what NBA uses. The NBA uses box scores to keep track of what player or what the player performance during his career. And there are two kinds of box scores. The regular box scores, which includes 32 as box scores, and among those 32 box scores, probably I'll be using 8 traditional important box scores such as games, points, assist, rebound, steal, block, and free throw percentage, and turnover. So here's advanced box scores, which is based on regular box scores. And I'll be using 7 out of 29 advanced box scores, which these sevens are very important, the most important out of 29. The first one is PER, player efficiency rating, which measures what the overall performance of a player during the career. Overall performance made up offense, defense, rebounds, everything. So OWS, offensive win shares, is uh, how a player contribute to the winning share of offense, and DWS, a defensive win share. So how the player are contributed to defensive win share of the game of the team, and win share is the win shares in general. Win share 45 minutes is the win share per 45 minutes, which is the whole game. And number 6 is VORP, value over replacement, which measures how the player is stacked up to the one that he's replacing during the game. And BPM, box scores based on minutes, which is how this players, the impact of players on the court when he is on the court, how the player impacts when he is on the court. These are the advanced terms that I'll be using to compare the players along with. So here is the result of my first result of box scores, which is regular box scores. I have performed two statistical analysis. First one on regular season and the second one on playoffs. Before I started plotting this, I try to make sure I chose the right data in ratio and the right plot that I have, which will convey the message that I want to that I want to show. So I chose violin plot instead of box plot. At first, I chose box plot, but I think violin plot is better than box plot because violin plots show the full distribution of the data, and it's useful when the data has more than one peak, So I use the violin plot, and as a result, I can see that for regular season, LeBron James has played more games in his career than Michael Jordan's, because he plays about 19 seasons and Michael Jordan only played 15 seasons. Total rebounds, Michael Jordan came on top for regular season. Turnovers, Michael Jordan is better than LeBron James. Assist, when it comes to assist, LeBron James tops Michael Jordan. And when it comes to steal, Michael Jordan. Blocks, Michael Jordan. Free throw, it's Michael Jordan. So for regular season, it is Michael Jordan. The winner is Michael Jordan. Then and under plots, it shows, you can clearly see it. When you look at it, you don't have to look for the answer. You can see it right away. The comparisons between two players. And for playoffs, it's a little different story. The playoffs, LeBron James steps up a little bit. He takes games played. He takes total rebounds. He takes blocks. He got more blocks than Michael Jordan when it comes to the playoffs. And Michael Jordan took steal, free throw, turnover, and points. So the second analysis for regular playoffs season playoffs is a tie. There's no winner. They came up. They share four apiece. So the first analysis is tie. This is tie analysis. So this is the result of advanced box scores for regular and playoffs. I chose radar chart for this section because radar charts is allowed to compare several variables in the way that appears less than cluttered and is easier to read than other types of graphs and charts. I have chosen 19 I plotted 19 categories, even though I only chose to compare seven of them. Seven of them. I just want to see how Radar Chart perform with all these data dimensions. So it turns out pretty well. For data ink ratio, I use gray as the background. Red color represents Michael Jordan, and the yellow represent LeBron James. And I plotted it in log scale too, just try to make sure it's to try to see the difference. But I like the log scale too, but I like regular scale plotting better, so I put it in here. Yeah. So here's the result. As a result, for regular season, LeBron for player efficiency rating, these are really close for regular season. Player efficiency rating, defensive win shares, offensive win shares, only value over replacement and box plus minus scores. LeBron James better than Michael Jordan. The rest, look at the data on the rest, the scores. These are really tight. You can see it on the graph too. This is really tight. And the graphs captures all these precisely. This is really nice. Now is the second part of advanced box scores, which is playoffs. The playoffs is a different story. Here's LeBron James stepped up. His PR is a lot better than Michael Jordan. His defensive win share, it's not as good as Michael Jordan, but his win shares overall is better than Michael Jordan. Offensive win shares, value over replacement, is better. Box plus minus, which is a lot better, and win share is a lot better. So this round is I think this round goes to my LeBron James. Even though regular season's tie, then when it comes to playoff season, LeBron James tops Michael Jordan, and the graph really captures and give me the answer that I needed. This is pretty good. In addition to that, I plotted what do you call that? Average performance, the performance of advanced box scores for the whole year, and this is for playoffs to see how they perform, how consistent the player is. So as a result, you can see Michael Jordan is more consistent than LeBron James. Even look at that, LeBron James PRs for a single season or per game is around 37, I think. But when it averages it out, it shrinks down to 28, and Michael Jordan is only 32 to 20. So the variations for LeBron James is pretty high. So when it comes to consistency, I have to say Michael Jordan is a little bit better than LeBron James, even though I'm not considering this category as I'm just curious what it looks like, and look at the graph. Again, it is showing what I needed. So after performing all the statistical performance tests, which is all tied up, Michael Jordan took the regular seasons and LeBron James took the playoffs. So here is the eye test. What's the eye test? The eye test is just very simple. It's just what do you see in a player? What do you like in a player? As for me, I like the player shooting, scoring in the last minute, how a player perform in clutch times, and this kind of data doesn't show it. The regular box scores or advanced box score doesn't show this kind of data. So I downloaded. There are another sets of data sets. Not this is just for, they call it shot chart. So it has a record of every player's or shot positions during the game. In order to uh, in order to perform this test, I downloaded randomly. This is a random choice. I chose Michael Jordan's 1997-98 playoff seasons and LeBron James 2016-17 seasons. I downloaded these two seasons before it. Okay, before I started plotting, I decided which plot do I have to choose, which color, and what kind of plot I want. So I chose hexagon or density plot. Uh, so I chose a hexagon density plot with log scale to show the result. I chose Michael Jordan as red color. For the color wise, I chose a little higher data to ink data ratio, because I wanted to see, how their position, the shot position, how they're making, how what the shots would look like. So I chose red for Michael Jordan, yellow for LeBron James, and hexagon density plot, hex bin density plot with log scale. Uh, the first one that I did was and then I plotted the first one. As you can see, the plot really shows where the players are taking the shots from. And like as you can see, Michael Jordan's is around mid-range shots. That's where they're coming from, and the LeBron James is around the rims and a little bit on the outside. So for further, I you know I for further analysis, so in order to get the detailed shots where they're coming from, I I extracted two columns from that data set, which is the shot range. The shot range, which has like for shot range, I chose four shot range. The first one is 16 to 24. The second one is 8. The third one is 24 plus, and the fourth one is 8 or shorter. As you can see, the results, for 8 to 16 feet. Here's all the 16 to 18 feet. It's all Michael Jordan. The results is 8 to 16 feet. Michael Jordan is make 70 out of 243, and LeBron James is only 9 out of 217, so 8 to 16, 8 to 6 feet. And Michael Jordan made 64 out of 243 shots in 16 to 20 feet. And LeBron James made 18 out of 217 for the same data. But when it comes to shot less than 8 feet, Michael Jordan made 96 out of 243, and here comes LeBron James with 146 out of 217, which is pretty high. And it is the density plots is showing that too, but it doesn't give you the correct. It doesn't show what do you call it, precisely where it's coming from, but it shows where the plots are cluttered around. So it is pretty. And all these, you can see all these plots captures where the shots are coming from, and when it comes to shots, Michael Jordan's are way more superior than LeBron James. And then I went further and to see how the player performs when it comes to clutch time. And I still use scatter plots, which works well. I still use the same scatter plots with the same color, with the same basketball in the shot charts. So when it comes to comparing player by the minutes, Michael Jordan you cannot beat Michael Jordan. LeBron James cannot beat Michael Jordan because I can win 0 times 0 minutes, which means it's less than 60 seconds. At first I thought 0 minutes, oh, that's no time. No, that's 60 seconds. Michael Jordan made 225 out of 243. LeBron James made 14. That's for 0 minutes. When time, there's 2 minutes left on the clock. Michael Jordan made 21, and LeBron made 20, which is pretty close. 4 minutes. 4 minutes. Result: Michael Jordan 30, LeBron James 15. When the clock's at 7 minutes left, Michael Jordan 23, LeBron James 16. When the pressure is high, you can see Michael Jordan has stepped up, and the graphs show exactly the colors that I have chosen. It's a perfect trick for this kind of data and this kind of presentation. Finally, here's awards and accolades. Everybody knows Michael Jordan won 6 NBA championships, and he did it 2 times, and he won 3 consecutive times, twice in his career, compared to LeBron James 4 times out of 10, which is 40%. And record-wise, Michael Jordan is a lot better. And besides the titles, there are some other records right there. And Michael Jordan beat LeBron James and all the way around over this. And I have chosen Altair regular, the same bar chart. Since the bar chart is simple to display categorical data effectively, I use bar charts for simplicity and try to use Altair, which I've learned during the semester. And it comes out perfectly. And so I say it's LeBron James who is trying to compete with Michael Jordan, and who comes up short at trying to capture the title of the greatest player of all time for NBA, because for statistical analysis they were tied, and for eye test clearly Michael Jordan won. And here awards and accolades, this is Michael Jordan again. So Michael Jordan is the greatest player of all time. In conclusion, I have to conclude that I started out very slowly with this paper, and it was a little bit taxing, because I had to find out what's all these charts, and I have to learn how to draw all this stuff, because since this is my first class of the data visualizations, and try to learn all these rules. But at the end, I found there's a lot of information out there to work on this, and the plots. I believe the plots I've shown and the techniques I've applied capture the one that I want to show. As a result, I think it is pretty good. I've chosen the right graphs and technique for this presentation. And for the topics, I think in NBA, if you want to be the greatest player of all time, you have to score. The score, you can have rebounds and blocks and everything but that kind of attributes or addition to scoring, but scoring is the most important assets you need to be a greatest player or the greatest player of all time, and you have to score consistently. Thank you very much.